Hello, so welcome back for the second example. This one is from the textbook. Similar problem, but just good practice. So a particle moves in a horizontal line so that its position from a fixed point after t seconds, where t is greater or equal than 0, is s meters, where the position function is equal to 5t squared minus t4. So the first one says find the position, velocity, and acceleration of the particle after 1 second. So we have the position function, so we can easily plug in 1 as our value of t, and we'll end up with 4 overall. So again, I'm plugging these in really quickly because you would just place 1 in where you see t. Now, to look at the velocity function, we first of all need to find the velocity function. We would end up with 10t minus 4t cubed by taking the derivative of the position function, and then we would plug in the t value of 1. And this would give me 6. I'm going to analyze all these in a moment. So acceleration would be the derivative of the velocity function. So we'd end up with 10 minus 12t squared. And again, we're looking at what's happening after 1 second. So we'd end up with -2. So this first one is telling me that it is 4 meters to the right of the origin. Okay. This positive is telling me that it is traveling at 6 meters per second. Okay. And then this is telling me that the acceleration at that point is -2 meters per second squared. Okay. Because there is a difference in sign between the velocity and acceleration at that point, that means that the speed of the object is decreasing there. So B. B says determine whether the particle is speeding up or slowing down at t is equal to 1. So I already went a step ahead when we were just looking in the last question. We said that the velocity and the acceleration have 2 different signs. So because vt and at have different signs, it's an indicator that the particle is slowing down. And then C says, find the values of t when the particle is at rest. So that means there is no movement. It is not speeding up or slowing down. So that's when our velocity is equal to 0. Okay? Velocity is a good indicator of speed. So when the question is talking about speed, especially if it's talking about being at rest, you want to investigate the velocity function. So let's set the velocity function equal to 0. And the goal is going to be to try to find the t values that make this true. So let's set this equal to 0 and solve. So I'm going to factor out a t first. Oh, even a 2t. And I'm going to be left with 5 minus 2t squared. So this would just be a t value of 0. For this, I would end up with t squared being equal to 5/2. So I'd be taking the square root of that, which could be positive or negative. But again, because of the restrictions in our domain up here, the only value that can exist in this domain is going to be the positive case, so positive root 5/2. Okay. So that's all the question was asking for this one. Find the t values when the particle is at rest. It did not ask us to find the coordinates where it is at rest. So D is saying find the time intervals on which the particle is speeding up and the intervals on which it is slowing down. So we need to be looking at velocity and acceleration and doing a sign analysis of this. So luckily enough, C helps us complete question D. So for D, we would want to test around the values that we just found. So 0 and root 5/2. And if we test around that, we would end up finding that between 0 and root 5 over 2, I end up with an overall positive, and at greater values than that, I would end up with a negative. And so now we need to work with our acceleration function, which was this, and we need to find values to test around. Because again, we're trying to figure out when are they both positive or both negative. So let's set this equal to 0 and even find the values we need to test around. So we'll end up with 10 over 12. Okay. I'm just going to simplify that to 5/6. And again, only the positive case is going to be generated here. So in our acceleration function, we're going to be testing at the point root 5 over 6. And if you plug these values into the calculator to get decimal values, just so that you know where on this number line to place it, root 6 over 5 is just slightly smaller of a value than root 5 over 2. So I'm just going to place it so that we can then look at where either they're both positive or both negative. So between 0 and root 6 over 5, if you were to plug a value in there into the acceleration function, you would end up with a positive. And then any value above that would be a negative. So now if we look at what regions we're seeing the signs being exactly the same. So we see that between 0 and root 6 over 5, they're both positive. Okay? But then between that and root 5 over 2, okay, this value is negative, and this value is positive. So those have different signs. So that would be an indicator that it is slowing down. But here we have both values as negative, so that's an indicator that it is speeding up. So it doesn't matter if it's both positive or negative, those are speeding up regions. So speeding up is happening for the t values between 0 and root 6 over 5. And if you'd like to rationalize the denominator for these, you can. I don't even think they did in the book, but. And then it's also speeding up between root 5 over 2 and infinity. And then it's slowing down in this green section here, where 1 is positive and 1 is negative, and that's between root 6 over 5 and root 5 over 2. Okay. And then the last question says, find the total distance the particle has traveled in the first 3 seconds. So similar to the last problem, you're going to test from the origin to any turning point. So the turning point we actually found was here. It was when it was at rest. So that is root 5 over 2, okay, until we reach 3, which is the end point that it wants us to test. So whatever's over here at 3. So to do that, we're going to test what's happening from time 0 to time root 5 over 2, and then we'll test from time root 5 over 2 until the time of 3 by plugging those values into the position function and subtracting them. So if you are to plug root 5 over 2 into the position function, I ended up just generating a decimal value. So I got 6.25, and then when I plugged 0 into the original position function, I got a 0. For this, I plugged 3 in, and I subtracted root 5 over 2 again. So the position at 3 is negative 36. And again, every time I'm just plugging it into this original function where t is. Okay? And then when I plug the root 5 over 2, we did it over here, we get a 6.25. Okay? So in this first portion, we end up with an overall distance traveled of 6 and 25/100 meters. In the second, we end up with negative 42.25 meters. But again, the positive and negatives do not matter. We're just looking at the overall distance. So disregard positives and negatives, just combine to find the total distance. So the total distance is 48.5 meters. Okay, folks, good luck with the practice.